Good morning. Today we will be learning how to convert second degree functions between all forms. Our learning goals today are to learn how to convert between all forms quadratic functions and how to find complex roots and the conjugate pairs of quadratic functions. So first of all, I started a little diagram here for you so that you can understand converting between all forms of quadratic functions. So we have three forms: standard form, vertex form, and factored form. So in our diagram here, what we have to understand is from standard form to vertex form, we use completing the square. So when we take our equation in standard form, complete the square, we get vertex form. From standard form to factored form, we use slide and divide or sum and product. So when a is equal to 1, you can just use sum and product. Now, from vertex form to standard form, we expand. From factored form to standard form, we expand. And if we want to go directly from factored form to vertex form, well, we can't. We have to expand factored form into standard form and then complete the square into vertex form. Also, vertex form to factored form, we have to expand to standard form and then slide and divide or sum and product into factored form. So that is how we convert second degree functions between all forms. Now let's see how this works. Okay, so I have here standard form to factored form. Standard form, you see standard form to factored form, I have to slide and divide. So let's do this. 4x, so I have to slide and divide, not sum and product. So that will get me x squared minus 12x plus 36, okay? Then what plus what equals negative 12? What times what equals 36? The answer for that will be negative 6 and negative 6. So that will get me x minus 6, x minus 6. Now I have to divide, so divide by 4, which will get me x minus 3 over 2, x minus 3 over 2, and then I take this 2 and put it in front of x, which will get me here as well, which will get me 2x minus 3 times 2x minus 3. So my factored form will be f of x equals 2x minus 3, 2x minus 3. So that is my factored form. I just slide and divide that, and we've got our factored form. Now let's go standard to vertex form. Okay, so I remember here, standard to vertex, completing the square. So let's complete this square. First of all, I have to factor out this 4. So how do I do this? I have to factor out this 4, which will get me 4x squared minus 3x plus 9 over 4, okay? And then I complete the square, so I put brackets for brackets x minus 3 over 2 squared, and then I subtract 3 over 2 squared, which will get me 9 over 4, and then plus 9 over 4. Then I can see that I can cross these out, so that will get me 4x minus 3 over 2 squared. So my vertex form is f of x equals 4x minus 3 over 2 squared. Okay, that is our vertex form. So important thing in vertex form is that we can identify easily our vertex. So our vertex here will be 3 over 2 and 0. Okay, because this is technically minus 0. Factored form, we can identify our x-intercepts very easily, and standard form, we can identify our y-intercept easily. So that is why we want to do this. So now let's go to another example, factored to standard. Factored to standard, we have to expand. Okay, so let's expand this. To expand this, we will get 4x squared minus 6x minus 6x plus 9, which will get us f of x equals 4x squared minus 12x plus 9. You see what I did here? I just FOILed this. I am expanding this. FOIL, FOIL. Okay, then I get my standard form. And you see that I used it as an example for my factored form, 2x minus 3, 2x minus 3, which is the exact answer that I got here. And then you see that I expanding this here, I got 4x squared minus 12x plus 9, which is my standard form that I had before, 4x squared minus 12x plus 9, proving that my answer is correct. Now, vertex to standard. Let's do this. So once again, expand. So x minus 3 over 2 squared will get me 4x squared minus 3x plus 9 over 4. And then I multiply this by 4, will get me 4x squared minus 12x plus 9. So f of x equals 4x squared minus 12x plus 9. Once again, the correct answer, my standard form from the beginning, the same standard form I got from my factored form, the same standard form I transformed into vertex form beforehand, showing that this is indeed correct method. Okay, so now we know how to do this. Let's go finding complex roots and conjugate pairs of quadratic functions. So what we have to understand here to do this is that the root of -1 equals I, so imaginary numbers. And an important thing here is, let's say I have your root of -4. Well, root of -4, I can separate this into root of -1 times root of 4. Then root of 4, I know that's 2. Root of -1, I know that's I. So the root of -4 is actually 2i. Let's say I have root of -3. I can transform this into root of -1 times root of 3. So my final answer will be I root of 3, because 3 I can't simplify any further. So let's say I have a equation here, a function here, f of x equals x squared plus 4x plus 13. And now I'm going to use the quadratic formula here. So negative b, so -4 plus minus square root of b squared 16 minus 4ac over 2a. So that's 2 times 1. I really don't have to write that. So that will get me -4 plus minus the root. So 4 times 13 is 52. Negative 52. Negative 4 plus 16 will get me -36 over 2. Negative 36 I can transform into root of -1 times root of 36. Root of 36, I know this is 6. Root of 1, I know that this is I. So here I will get -4 plus minus 6i over 2. Then this 2, I can cross this out with these 2's. That will get me -2 plus minus 3i. So here, now I'm almost getting my roots here. So you have a plus minus here. So my root will be -2 plus 3i and -2 minus 3i. So that is how you find roots, complex roots. It's the exact same method as when you find real roots, but when your square root here is a negative, then you have to use complex numbers to be able to solve this. Interesting here is that your answer, your two roots, are always conjugate pairs. And that means that when you multiply them, when you have to put them in factored form, okay, you have to put them in factored form, x minus, so this will be my root, -2 plus 3i times, okay, x plus -2 minus 3i. When I multiply this is important, but when I multiply this, I will get a number without the i's. I will be able to cross the i's, and then I will get my standard form back. So this is really interesting. Every complex root that you find when you're finding roots of a quadratic equation, they will always be conjugate pairs. So then when you multiply them, you will be able to cross out your imaginary numbers and then get normal numbers, real numbers back again. Okay, so let's do some examples. I have your f of x equals, so this is vertex form, x plus 2 squared minus 16, okay? And I have to transform this function in vertex form into standard and factored form. So let's do this. Vertex into standard, I have to expand. So that will be x squared plus 4x plus 4 minus 16. You see I just expanded this. Then that will get be x squared plus 4x minus 12. So f of x equals x squared plus 4x minus 12. That is my standard form. Now I have to transform this into factored form. So factored form, I see that my a is equal to 1, so I can use sum and product. What plus what equals 4, that same number times that same number. This really looks really ugly. Equals negative 12. So my answer for that will be 6 and negative 2. 6 and negative 2. So my factored form will be f of x equals x plus 6, x minus 2. That is my factored form. So my second example I'm going to give you here, so I have g of x equals x squared plus 3x plus 4. I want to find the roots of g of x. So quadratic formula. Negative b, so negative 3 plus minus the root of b squared, so minus 4ac over 2a. I'm not going to write that a. So that will get me negative 3 plus minus the root of, so negative 4 times 4 is going to be negative 16, then plus 9, that will get me negative 7 over 2. Negative 7 I can transform to root of negative 1 times root of 7. Root of 7, that's a prime number. I can't simplify that any further. So this will get me negative 3 plus minus I root of 7 over 2. And then, so my roots here will be negative 3 plus I root of 7 over 2 and negative 3 minus I root of 7 over 2. Once again, these are conjugate pairs. Okay, so now I'm going to give you some homework questions. I hope you will be able to understand this very well. Here are your homework questions. This is what I want you to do. I hope you were able to understand this thoroughly, this topic thoroughly. Thank you very much.